here we are to present RefactorFirst. And let me first say, the main presenter on this talk is Jim. And he actually asked me to give him the stage for this talk, right? So that is an interesting request, right? So I thought, what can I present to give Jim a good stage and to kind of give him a good entry to explain what his tool is doing and how does it help. So I thought I'm gonna tell you a little bit of a long story, hopefully short enough that Jim still has time to present his stuff, of how I met Jim and how I became speaker at this conference. So the story takes us back to 1992, where Snap and Rhythm is a Dancer was still #1 in the charts. And in the same year, technical debt was first coined by Ward Cunningham as a metaphor when he explained to his manager certain trade-offs in software development for actually a financial software. So he actually thought it would be good to borrow a concept from the financial domain to explain it to his manager that understood the financial concepts. And if you want to actually know more about this, there's a very nice 5-minute YouTube video where Ward explains what happened back then at that time. So what is technical debt and how does it fit into our today's presentation, right? So technical debt, and I bet 100% of people have heard of it by now, is the gap of making a change perfectly, modifying the software, preserving the architectural design, doing the best programming practice, updating your testing, your documentation, and everything perfect, and making the change work as quickly and as fast as possible. So the metaphor I used here, right, is the duct tape and the hammer. And I believe many of us have used duct tape previously when doing software development, although, right, in our hearts, we often feel we want to use a hammer. So now, when I say this, right, a lot of people, when they hear technical debt, it has actually a very bad reputation, right? So you think immediately about the increased maintenance cost because your software is not as good as it used to be anymore. New features take longer, and the more debt accumulates, the longer it will take, right, to maintain software. Bug fixes take longer, and you also potentially introduce more bugs over time. So the risk in a software project is really that the technical debt gets out of control, right? And you're at some point at a point where you can't do anything more than just maintaining the product. But on the other hand, there's also benefits of going into technical debt. Yeah? So for example, if you want to get a release quickly out of the door in short term, it might be good to do a quick and ugly or a duct tape-like fix on a piece of software. It also lowers the cost of a current release, and potentially you can release earlier. And I think one of the examples where we have seen it working very well is, the customer has a problem, they need a very urgent bug fix. So you're helping a customer potentially immediately by fixing something quick. So now that comes back to the question now, technical debt, what is it bad? Is it good? And we can look actually at the similarity, right, to financial debt. You can buy a new TV today and pay it off later, right? So you're going into debt, maybe you're paying a little bit of interest. So is this a good thing to do or a bad thing to do? Well, it can be actually very beneficial. For example, if the World Cup final is on tonight, right? And you have a new TV to watch it with your friends. At the same time, right, you understand there's these attributes attached to the debt, like the interest, the things that you have to pay over time, like the principal, the things that you have to pay eventually, right, to pay off the debt, and the risks of that these debts become uncontrollable, and you can end up at a point where you're only paying interest, but you're not essentially have any purchasing power anymore. So technical debt is neither good or bad per se, but it's a trade-off that, if you wisely choose in a given situation, can give you a benefit and an advantage. The thing is, in financial debt, it's actually relatively easy to manage your financial debt, because typically you can get a statement from the bank and you know exactly how much debt you have and how much interest you pay. But in software, there's a lot more uncertainty. So it's a lot harder to estimate, what is my overall debt? How do I estimate the interest? And then maybe even most importantly, how do I make educated decisions on what debt to pay off and what debt I can leave in the system? And here's a little spoiler alert, RefactorFirst helps you with that. So in 2010, the software engineering research community actually recognized there's a lack of research around the management of technical debt in software projects. And I've linked here a good paper that is a 2010 position paper that summarizes the challenges that were recognized at that time. Since 2010, there is a whole body of knowledge in the computer science research, and that is over 1,000 publications that are hovering around certain aspects of technical debt. And if you actually look at the timeline of these publications, we can see each year from 2010, there's more new publications published about technical debt. The source of this data is, by the way, scopus.com from Elsevier, and that is the company I work for. So back to the story now, how I met Jim and what I can do for him today, right? So in 2011, there's the first connection, right? So at that time, me and my colleagues, Carolyn Seaman and Forrest Schall, we published a paper on prioritizing design debt investment opportunities. So we kind of asked the question, what debt is worth paying and what not? So in this paper, we created a more or less theoretical cost-benefit model that relied on certain information, giving developers more insights into what is more beneficial to pay off. And in this paper, we introduced actually and considered the factor of the principle. So we looked, for example, at change frequency of classes to predict, is it really worth fixing a certain class in Java? And like a good theoretical physicist, and this is also the link where this t-shirt comes into play, we left it with this theory. And luckily, Jim stumbled over this paper from 2011, a few years later, and thought this was a good idea to test out. So all the credit of building the tool that you're going to see now goes to Jim. And he turned this idea into reality. And in the end, he was actually kind enough to ask me to open the stage for him today for this conference. So thanks, Jim, and I'm going to give over to you to present.
All right, thank you very much, Nico. It's an absolute delight to have you. All right, there we go. Should do it. Okay, so as Nico mentioned, my name is Jim Bethancourt, and I have created this tool called RefactorFirst. And my sincere hope is that it will be useful for you and for your team, so you can focus on what matters, which is delivering features and making your customers happy, and ultimately having less stress in your life and enjoying your time more with your family and your friends and your coworkers. Because that's in the bottom line, that's really what matters is relationships and enjoying life. So, all right, here we go. So first, I'd like to start off with the state of technical debt today. So the truth is, large code bases are painful because they often sprawl. Architects and developers have different ideas, and as time goes by, people change on the team and people have different ideas, but a lot of times the code that's already there is left alone. And as a result, a lot of times developer productivity is poor because of these changes, because of these different ideas that come in and go, and also simply because different pieces of code end up in different places. Sometimes we'll see copy paste development, or we'll see half fixes, but then they're not fully implemented because there's time those run out, or just again, it's so large that it's hard to wrap your head all around it. Then also again, developers and architects may not be able to identify the root causes of the degrading team productivity, again because there's only so much velocity that a team can carry, and the customer is always hungry for more features, and there's often times more than not it's easier it's more, you get told you have to focus on what's ahead of you, not what's slowing teams down. And again, also because teams change, the institutional knowledge leaves with those individuals. And even then, if somebody has been around a long time, they may not realize what the actual problem is that's underlying the issues. And again, as I mentioned before, also customers expect the same velocity as the code base grows, even if there's more code to work with, to deal with. And Agile is a great process, but there are a few small problems with it that lead to technical debt accumulating. So Agile processes focus on visible value, which is features and bugs. So features being positive visible value. This is delivery value, whereas bugs are negative visible value. These are problems that customers see. However, technical debt is invisible negative value. This is stuff that the customers can't see. This is stuff that your product owners can't see. Whereas positive invisible value would be architecture. So if you Spring Boot or Java EE or Jakarta EE rather, or Micronaut or things along those lines, or if you use a build system, Gradle, Maven, those are positive invisible value that help to propel your project forward quicker. So again, technical debt is negative invisible value that's invisible to see. It's a broken build system. It's technical debt. It's a poor design, things along those lines. Those are, again, negative invisible value. And as a result, because technical debt is negative invisible value, it's hard to identify and hard to prioritize. And product owners may not take ownership of this negative invisible value because it doesn't end up on the backlog. Because they say, look, it's not a feature, it's not a bug, so I'm not going to own that. They may say, of course, they do own it because it is a very real problem that they have to deal with, and that is impacting their feature delivery and their bottom line. But unless they take ownership of it, not much will happen in a measured way. So there are a lot of code analysis tools that are out there today. You have SonarQube, PMD, Find Bugs or Spot Bugs, Google Error Prone, CheckStyle. There are others as well that are quite nice. However, they also have their own problems. You run analysis and the output is frequently very overwhelming. You have, especially for large code base, and so you're wondering, where do you start? And also for a lot of these, the change history is not taken into account. And so you don't know what your hotspots are. And often a lot of these focus on what I like to call tactical improvements, where they're on a line by line kind of, oh, you didn't use the return value. Oh, you have too many methods in this chain, or you're passing too many parameters, or things along those lines basically are what come to mind. These are, again, improvements on a line by line basis. They're not looking at the larger design of the system. And also these issues are prioritized by severity, not by effective use of time. So these severity buckets are just that, they're buckets. They're not very granular. They don't give good guidance on where you should spend your time. Yes, certainly, of course, take care of the severes and the highs, but which one should you start with first? And again, these also don't address design, which is sort of the Achilles heel of teams and technical debt that's slowing down those teams. So you have also architecture analysis tools. This one is from Sonograph by Hello Tomorrow. It's a great tool. I've used it before. It's very powerful, very impressive. Others are Structure 101 from Headway. I know both of the folks that have created these tools. These are really powerful tools that help to identify dependency cycles. The output, though, can be overwhelming. As you can see here again with Jenkins, this is the analysis of the Jenkins code base, and it's really, really thorough. However, if you were to ask me where to start, I would say I don't know. I would have to guess probably the ones that have a lot of lines going in and out of them are probably the worst ones. But is that the best place to start? I really don't know. I couldn't give you a good answer to that. And also for both of these, for all the tools of this type, for architecture analysis tools, change history, again, is not taken into consideration. And so as a result, that's kind of a missing piece of the puzzle. And also, you don't have any immediate indication of the best place to start. So just like I mentioned before, I could guess, but I could very easily be wrong. And for a lot of these architectural analysis tool vendors, they'll say that the ideal use is at the beginning of a project before things get too bad. However, a lot of times in a lot of situations, you end up with teams do adopt these tools, but it's almost too late. Things are already in a bad state. So my goal with RefactorFirst is to help teams figure out how to climb themselves out of this hole that they've dug themselves into. You also have source code repository history analysis tools. These are also really powerful Git history analysis tools. They're really impressive. They're fairly new, on the market. However, they tend to focus on churn and on pull request cycle time, which are more lagging indicators rather than leading indicators of where the problems might be. And then also many of them focus on the performance of individuals rather than teams. And you can lose some context around the actual performance of individuals, because you might have somebody who's working solely on new features, and they are but they know what they're doing, and so they have a high commit count. But then you have another developer who is a maintenance programmer, and they're constantly having to figure out what the problem is with this particular bug and why this is a problem, and then go in and research, talk to people, and figure out why what's broken is broken. And so you see this disparity of what looks like the performance of individuals, whereas when they're really doing their jobs that they're supposed to be doing, but when the numbers float up to management, for example, they lose that context. And so is this really something that we should be measuring even, is the number of commits by an individual? So many of these also don't identify root causes. They just report simply on the churn and the PR cycle time. Some do report on root causes. However, they again put these into broad buckets of severity, and that's really about it. And so they prioritize by severity, but not effective use of time, because they're not, again, combining these two dimensions effectively of severity and churn. So why RefactorFirst? So I created RefactorFirst because I know that design debt is what ultimately slows teams down, much more so than the tactical line-by-line technical debt. But I also wanted something that was easy to understand by everyone, both developers and non-developers, such as product owners, managers, QA folks, BAs, so that we can all understand that the team owns this debt. It's not just the developers, and there's not some special tool that's hard to read and understand. I wanted something very easy to understand. And also I wanted to provide actionable guidance, so that folks know, okay, given the limited amount of time that I have at the end of the sprint, because I finished all my features, where can I spend some time to go pay down some of this design debt, this technical debt that's accumulated? And I also wanted to allow for the, again, as I just mentioned, for developers to make the best use of their time, again, at the end of a sprint, or also in a planned maintenance effort. So if you want to take take a sprint to pay down technical debt, you want that time to be well spent, because time is precious. It's this limited resource that once it's gone, we never have any more of. And it's arguably the most important resource that we have as software developers. So I wanted to make sure that whenever developers use this tool, that they can use it effectively and to make the best use of their time. So are there any questions in the queue? All right, I'll take that as a no. So I'd like to talk about what is RefactorFirst, but first I'd like to give you a little bit of background. So there are two strategies to pay down debt. Like Nico mentioned, there's financial debt. So we can take a look at the strategies. First is the smallest debt, which is commonly called the snowball method, which is that you tackle the easy debt first. So if you have multiple debts, multi credit card debts that you've racked up, and one is maybe $100, one is $1,000, and one is $5,000. Well, the snowball method says pay down the $100 one first. However, you won't necessarily you will continue to accumulate the interest at a higher rate if, say, the $1,000 is has a higher rate of interest, but you'll have that victory, that hooray that you get whenever you're done paying down that debt. And then the other approach is highest interest debt. So this is called the avalanche method. This takes discipline, but it minimizes the interest in the long run. So if the $1,000 debt has the highest interest rate relative to the $100 and the $5,000 interest, and so you're paying 20% interest on $1,000, but you're maybe paying 2 to 3% interest on the $5,000, then you're going to have more interest in the long run that accumulates over for that $1,000 debt. And so you want to pay that debt down first, get it off of your books. And so this again takes discipline, but it minimizes the interest. And then of course the third one that I just realized, of course, is to simply write it off. So you don't bother with the debt. You just leave it alone. You just leave it alone. You say, look, we're gonna write that off. We're gonna walk away from it. We're not gonna touch it at all. We're gonna take it as, look, this is our life. We're gonna declare bankruptcy on that particular debt. So let's start instead let's do a combination factor of both the snowball and the avalanche. Let's start with the small high interest debt. So to identify the debt, first we need to identify our God classes. This is the particular smell that Nico and his colleagues focused on in their paper. They focused on God classes in the paper that he mentioned. And so what is a God class? A God class heavily accesses data of other simpler classes. In this case, this is access to foreign data. And so they access at least 6 other classes. And they're also large and they're complex. They have more than 46 non-getter-setter methods in their classes. And they also have a low cohesion between the methods belonging to that class. So if you see this tight class cohesion, that's the metric here at the bottom. So the methods have only to do with less than a third of the other methods in that same class. So you almost have 3 classes living in a single class that should really belong in separate classes. And so this God class, along with multiple others, were quantified by Michel Lanza and Radu Marinescu in the book Object-Oriented Metrics in Practice. It was published in 2004, and it's available from Springer. So I was able to snag a copy of it, and it's a really good book. It's definitely worth your time. And my plan to implement more smells than just the God class in this in RefactorFirst as time goes on. So why focus on God classes in particular? So Nico and his colleagues found that that God classes were 5 to 7 times more change prone. This probably has to do a lot with the fact that they're already so big, and that they pulled in a lot of functionality. As I mentioned, there are almost 3 classes that are really living inside of a single God class. But surprisingly, and perhaps even more important, they're 4 to 17 times more defect prone. And they're a big offender among code smells. So as you can see here on the right, this was a chart from the paper that Nico and his colleagues wrote called comparing 4 approaches for technical debt identification. So as you can see here, the 1.0 and all these numbers right here were an analysis from an analysis that they did of Hadoop across different releases. And so they calculated the bug fixes, and they also tracked the change proneness of the classes. This was quite a number of releases. And so they found that each of these code smells that were from Lanza and Marinescu's code smells that they identified, that God classes and dispersed coupling were the biggest offenders. And then also that there were quite a number that had modularity violations as well, and that they also tracked multi-threaded issues. And they found that actually, I didn't mention it here on the slide, but whenever you combine modulator violations, God classes, dispersed coupling, and multi-threaded correctness, there was, if a class that contained all 4 of these symptoms, there was a 1 in 3 chance that a bug would be committed in the future to that particular class, which is really, really impressive. So if you could, if knowing this information, it's really a powerful measure to identify what potential classes are that could be buggy, and addressing those problems before they actually happen. And removing God classes and breaking apart God classes is also key in a journey to microservices. Chris Richardson had identified this in one of his books and talked about it. And also, I started out with God classes simply because the rule was available in PNB. So just like you, I wanted to make sure and try to get something out the door quickly, so that it could get into your hands. So I'd like to introduce RefactorFirst to you. So this is the graph that is generated by RefactorFirst, and as you can see here, we have both the change proneness, which is the y-axis, and the x-axis is effort. So again, the effort is going to be how much work will it take to fix and to make a class ungodly. And the change proneness is the relative code churn. And I'll go into both of these in just a moment here. So this is the graph that's generated. It's easy for managers and non-developers to understand. So again, because typically, as you've heard before, a picture is worth 1,000 words. And then so it also lists out God classes by the numbers. So this is a table that's generated that's right below the graph. And so you have the list of classes. This is only a small subset. This is also Jenkins. So I should point out that this is the same code base. This is the Jenkins analysis. This is only for the God classes, but you can clearly see, you can get an idea of just where you can get a better idea of where you might want to start. So I'll give you a hint. It is the priority. You calculate the priority by taking a look at the change proneness minus the effort. So again, as a result, you want to start here at the top left, and this is going to be the number 1 priority because it's going to be the easiest to fix, but it has the highest churn. So again, churn shows that there's probably a problem with that class, and you want to try to take care of it and get rid of it. So here again, you see this is the same data again as a table, and you have a priority of 62. And so that's again calculated by the change proneness minus the effort. I've also included the method count, which is the size of the circle. And this is exactly what Nico and his colleagues did in their papers. They used the method count as a rough gauge of size. And I also included the most recent commit date in this table, so that way you can see roughly how recently what the recency bias is of the team, and what so maybe you can say, okay, well, I've worked on that one recently, I'll take that for example. And also the raw commit count. So you can see here the queue has had a significant number more commits than the file fingerprint storage and the icon set, but they both end up as high priority items because they constantly have the same amount of churn, the same degree of churn. And I'll get into that calculation in just a minute here as well. So now you'll see here towards the bottom, you have this update site and abstract build, both have the same priority, and the node and URL validator test both have the same priority. This is because, again, you have the change proneness minus the effort rank. So the real question here is, okay, well, which one should you focus on first? In this case, it's completely up to the developer or to the team, and maybe you're more familiar with one than the other, or maybe you're really hankering for a challenge, and so you want to pursue the one that has a higher effort. again, it's up to you. Personally, I would say I would go for the one that requires less effort rather than more effort, but again, it's entirely up to you. So how the results are calculated. So Nico, you'll recognize this this table. This is from the presentation that you and Carolyn Seaman gave. And this is the URL where you can find it. I've also listed it in the repository, on the repository README. This is free to view. So God classes are calculated by taking and calculating the individual method, individual ranks values for each of these different metrics here. So you have weighted method count. All of these are calculated, and then also for access to foreign data and for total class cohesion. And then each of these individual metrics are ranked. So as you see here, 107 is the highest value and 47 is the lowest value. And then so they receive the highest and the lowest rankings respectively. Here again, 9 and 1. And then same thing with total class cohesion. You see that 0.219 is the highest here, the lowest here, or the highest, yes. And then God class 1 has the highest, and so as the lowest, and so it has each of these have respective ranks, and so these are ranked. And then you have the access to foreign data. So again, you have here 7 is the lowest, and you have 34 as the highest, and so each of these are ranked as well. So then you have so each of these ranks are then summed, and then you have each of these sums are then ranked. And that's how we end up with the x-axis calculation. So again, effort minus principal. Effort is the principal, and so again, each God class characteristic is ranked, and the ranks are summed, and the summed ranks are ranked. And then to calculate the change proneness, we'll look at the number of total commits of a file divided by the total number of commits in a code base since the first commit of that file. So this generates an age-independent churn measure. So if you have a really old file, just like we saw here for the queue, it will show up still. It will show up right next to icon set and file fingerprint storage, just like an update site will, because it looks like queue and update site are probably quite a bit older. Same thing with abstract build, but it also gives a chance for icon set and file fingerprint storage to show up in the list as well. Because if we strictly used a raw commit count, the icon set and file fingerprint storage and URL validator test would simply fall off, even though they are brand new. So this allows for us to take these into account and show that these have a relatively high churn since the first time they were committed relative to even to old classes. And so the original algorithm also included bug count. This can be difficult to capture, but may be incorporated in the future, because this would involve, this would require that developers tie into or are diligent about committing against particular bug counts or bug tickets, for example. There is the possibility of taking in parsing the commit messages to look for a certain word like bug or fixed or addressed, or maybe things along those lines that would hint at the presence of bugs, but may not necessarily be conclusive, conclusively indicate bugs. So that could certainly be taken into account in the future as a way to identify a bug that has been committed or that has been fixed, basically. And again, so to tackle the priority, we're taking and subtracting the effort from the change proneness. So any questions so far? Any questions? All right, great. So how do you use RefactorFirst? So to find it, you can go to, I registered the domain name www.refactorfirst.org, or you can go to GitHub and to the repository github.com/Jim-Bethancourt/RefactorFirst. And if you are also a GitHub user, and your project lives on GitHub, you can use Sonatype Lift. I'll show you both of these in just a moment. So to run it, you'll need at least Java 8, and you'll need Maven 3, and you simply run this Maven command, this Maven goal, and it will generate the RefactorFirst report.html file and a Google chart that generates the chart. And so this does work both on single module projects and multi-module projects. You simply need to run it at the root of your project where your Git repository exists, and then it will take and scan the entire code base. It uses PMD, which only requires source. It does not require that your project is built. So you can get it working very quickly. For larger code bases, though, I do have to warn that it can take a while. Not so much because of the PMD scan, but if it's an old code base, it can take. I'll give you, or as a frame of reference, it took to run it against Jenkins, which had about 33,000 commits. It took about 10 minutes. So again, just so that way you're aware of about how long it will take. It doesn't work with Gradle at the moment. However, the folks at Sonatype have contributed in a piece that they'd added, a way to run without needing to use to have a Maven project in place. So I'd like to move that over to this report generator here, and it will be able to work with Gradle. I'm hoping very, very soon when I can find some time to work on it. So you'll still need to use Maven to run it, but you won't need to have a POM file. It'll generate a temporary POM file for you. What next? So we've got. So let me go ahead and show you the output of the reports here. Just a moment. Okay. So here you have the repository, and I have again a sample chart here. This is from the JSF from ice faces, from prime faces rather, Apache prime faces. And so they were courageous enough to share their God classes and from their PMD report. So I said, okay, I know that project has God classes. I'm going to use that one. So thank you folks very much for the Apache Trinidad Tobago team for sharing that and making that known. So then also again, you can make it as part of your Maven build if you want to. So for example, if you want to make it a Jenkins report, you can take and capture that and put it in and make it part of your build. I have this configuration here of show details. So it will actually display the specific God class metrics. This is particularly useful for researchers who want to look at the weighted method class, access to foreign data, and total class cohesion metrics. And then also, if you want to make it a report as part of your Maven build, as part of your Maven site, you can use this. However, I stopped supporting it as a version 0.20 because of a known bug in velocity. And then also that I showed, explaining out here where to find the report, but and then also if you want to take and find and look at the that PDF that I showed you where the table was on how things are calculated, it's right here. And then also some future plans. So the RefactorFirst report itself is right here. As you can see here, I have it as in the Jenkins code base. The RefactorFirst report is here, and so it is interactive. And somebody wanted the ability to make and navigate it like Google Maps, so I went ahead and implemented that. But you can see here, you can also hover over it, and you can see what the effort what the effort is, and what the priority is, and also what the method count is. So if you wanted to take in, you have a very large code base, you can drill in and you can see, okay, where the clusters are for that particular, typically the ugliest code. So you want to focus ideally on, again, this upper left corner right here, and then work your way towards this main line right here from where x equals y in the line in the graph. And so as you can see here, this is going to be the urgent and the important. This is typically a little bit more urgent, and this is more important because and then this stuff you just leave alone, because as you can see here on this graph, these guide classes, they don't change. Yes, they're hard. They might take a lot of effort to fix, but you want to leave these alone because they don't change hardly at all. So this is the kind of debt that you really want to write off. You just let it ride. You don't worry about it. And here is the table. And I also included a legend in case you're wondering, in case your colleagues are wondering, again, what the x-axis is, what the y-axis is, what the color is, and then also what the circle size is. And again, it's the same chart. This is full blown. And then you'll notice here that the priority goes negative once this x equals y goes, the interest minus the effort drops below 0. So certainly take and make it to where it starts at 0. But again, that's just, and so I may implement that at some point in the future. And then what else? So let me go ahead and finish up here. So now what? So what I would recommend is that you use the Java method reference diagram plugin for IntelliJ. So this will actually generate these right here, these graphs. This is a free plugin on IntelliJ. So here's the icon set. It was one of those guide classes that I mentioned, and as you see, you can see there's some islands here of classes of methods that could probably be refactored out into a separate class. And the same thing with abstract build, which is one of the top offenders. So you can see, as you can see here, also it provides with quite a number of, it indicates that there are a number of methods that really don't have to do much with the other methods. And some of these also that are higher up in the food chain that could possibly be pulled out into separate classes as well. This can provide some guidance. And this is also, again, it's also an open source tool, so I may be able to take in and capture some of this logic and put it into RefactorFirst to provide some guidance all in one place. So again, this is where this method reference diagram is located. If you want to capture that URL, it's very handy, very powerful. And to use it, you just simply right-click on your class and then go to diagrams, and then click on show diagram, and then click on the Java reference diagram there, and then voila, you have your method reference diagram. So future directions, I'd like to find classes that use 20+ types. This is indicative, I'm thinking, of a potential modularity violation, while also using sort of an in-based analysis rather than roughly an in of 1.7 to identify dependency cycles. I'd also like to possibly look at classes that have a high cyclomatic complexity, because that would also indicate design issues and potential bug proneness. I'd also like to incorporate test coverage and mutation coverage, and make that so the way folks can get an idea of how much risk there might be in changing a class, and how much effort would it take to take and make it safe to refactor those classes. And mutation testing in particular, I would strongly suggest that you look at pytest.org. So this is effectively looking at your tests and testing your tests. Really cool tool. It's drop-in, and it's super easy to use. Definitely suggest that you look at it. And also, I'd like to improve Git analysis performance to make it multi-threaded, because this is an embarrassingly parallelizable, problem. And then also, I'd like to pop way down the road, develop an IDE plugin, and perhaps sooner a CLI runner. I'd also like to allow for multi-repo analysis, to allow for a portfolio approach to analysis, because a lot of microservices, you don't want to measure those just only in isolation. and also measure metrics in other languages through leveraging the Graal VM. So again, this is also based on National Science Foundation funded research, roughly what I think it was $600,000. So not a small amount of change. So this is by Nico and Carolyn Seaman, Forrest Schull, and Michelle Shaw were the authors on these papers. And so if you want to find me, I lead the Houston Java Users Group, and I'm also on YouTube. If you want, I've recorded other sessions where I'm posting Java User Group talks. And also, I'm on LinkedIn and Twitter and GitHub if you'd like to connect with me. And then also, Improving has talks every Friday. You can register for them at improving.com/virtual events. And if you want to look at past talks, they're on youtube.com/user/improving enterprises. So thank you very much and enjoy RefactorFirst. So got some questions. So does it only tackle God classes or other anti-patterns? So right now it's only God classes, though I am actively working on identifying classes that have 20 or more classes that they use sort of to measure. I forget, I always get them mixed up, afferent or effort coupling, but yes, it's definitely something that's in the pipeline and that I hope to deliver soon. And have I run on my own code? Yes, this is surprisingly a small code base. And the only metrics that it found, I can show you here actually, were on it, were the test classes that I used. So here's RefactorFirst output, and this is again a sonotype lift. So it's free to use if you have an open source tool, an open source project that you have. And again, these are classes that I copy pasted from the Trinidad and Tobago project. So again, console, attribute handler, sorter, and attribute handler Java 11. So again, all of these are simply classes, and so you can run it. Again, it's free tool to use, and it provides both the chart and the graph here, and the hoverovers. So it's quite a nice tool. So again, if your class on GitHub, you can go to lift.sonotype.com and then sign up. You can use GitHub as your account. And let's see. All right. Yes, I'll definitely continue to work on the Gradle plugin, and then also so right now the POM at the moment only is supported at the root of the project, so again, once I get get it working to where you can run the project you can create it. If you want to, you can take and create a dummy POM at the root of the project. It only needs to have just the project declaration, and that's it. And then what else? So thank you very much. And thank you, Michaelis. I'd be delighted to receive your pull request, and I'm going to work on it and try to get a release out fairly soon, and then start incorporating more small features in as we go. And thank you all so much. Are there any other questions before you have any time? I think we have maybe about a minute left. All right. And thank you again so much, all of you. Thank you, especially Nico, for opening up the presentation. It's been an absolute delight having you. And please use RefactorFirst. Let me know your feedback. I'd love to hear it. The best way this tool will get better is through your feedback. Thank you so much. Have a great day. Enjoy the rest of the conference.